Welcome to this video in which we will demonstrate the requirements verification function of COMET. We will show this using a model that we have built for a case study that we have done on a ship conversion project, in which a ship that was originally fully powered by diesel generators would be converted into a ship that can be powered by both diesel and methanol. There will be a link provided in the description of this video to a presentation of this case study in case you would like to have more information on this. Here is where we see what we call the element definitions browser, which is where all the building blocks are defined that we need to express the ship as a model. For each of these building blocks, we need to define at least two things. Firstly, we need to define whether a building block consists out of any of the other building blocks. In doing so, we basically define the product tree of the system that we are designing. And secondly, we have to define the parameters that we want to know about for each specific building block. If we, for example, look at our top level building block, which is the ship itself, we can see that it consists out of three other building blocks, which are the auxiliary systems, the electric plant, and the hull structure, which are these building blocks that you can see here. For the rest, there are some parameters defined, for example, the endurance parameters and the ship stability parameters, which are all parameters that we required in order to show that we still meet the requirements that were specified for this case study. A parameter can be made option dependent, which means that it stores a separate value for every defined design configuration or design option, as we call them. Here we see three different design options defined. The first one is the original design option, which is the ship that was fully powered on diesel gensets. The second one is the conversion ship that is powered by both methanol and diesel. And the third one is the design option where all of the gensets are methanol gensets. Further in the switch column here, we see that all of these values are computed, which means that an engineering tool that is connected to this model is calculating the value for us based on input data that the tool gets out of this model. Now, a key advantage of using a central MBSE model like this is that you will have all the parameter values that are required to check whether your design fulfills the requirements stored in one place and that they are always up to date. And what this allows you to do is, if we open our requirement specification, the requirement specification for this case study, we can actually link all of the requirements for this case study to the respective parameter in the model. So for example, we have two endurance requirements here, one requirement that specifies the required endurance on methanol and one that specifies the required endurance on diesel. We can link those to the respective parameter in the model. Now, for this model, we have already done all of that. And what this allows us to do is for each of the design option to automatically verify whether we still fulfill the requirements. So if we, for example, do this for the design option that is running fully on methanol, we will get the results here. And we immediately see that we are not fulfilling a couple of requirements here, which is one, the endurance on diesel, which is quite logical in a sense that we don't have diesel on board. But we're also not complying anymore with the requirement that says that our list angle has to be between -0.5 degree and 0.5 degree in the positive direction. And we can actually check this in the model under the ship stability parameters. If we find the list parameter for our fully methanol option, we see that indeed it is lower than 0.5 degree of negative list. So that's correct. To conclude, I really hope this video shows the value of having a central MBSE model of a design, where a requirements verification function like this enables you to very quickly see which requirements a design is already fulfilling and which ones not. This can really help an engineering team with prioritizing their efforts and prevents them from having to spend time on improving an aspect of the design that already fulfills the requirements. Thanks for watching.